All right. Important announcement, very important. According to the syllabus, you have this upcoming 2 tests. Let me remind you of the dates. Tuesday, October 1st, you have this mainly written test. Okay, that's going to be 10%. Okay, you can find it in the syllabus. The week after, October 8th, Tuesday, during your registered lab session, you got this lab test number 1, that'll be programming, and that one is 20%. From my part, I will give you a precise guidance as what you can expect on Friday. By the end of Friday, I'll send you the guidance. Okay, and then I think your written test is coming first, depending on how we can cover up to. So I would say everything I'm going to cover up to maybe next Wednesday will be covered. Okay. However, I think for your benefits, I'm not sure if that'll be useful to you. I'm just proposing the idea. Maybe next Friday, I can hold a mini review session for everybody, and then you can study the slides, study everything I told you to, and then come and ask questions. Does that sound useful? Okay, I'll record the session anyway, so if you really cannot make it, that's okay. Okay, just to help you. All right? I'll make it more precise in the announcement. I just want to remind you. But I would say pay more attention to this test because there's 20%. Okay, I will tell you my expectation in the guidance, but you got to be reasonable, right? At least submit something that compiles. I'll give you the practice question as well. Okay, don't worry too much. We might be a little bit behind the schedule according to the syllabus, but it's only tentative. I only test you what I teach, okay? So you don't have to worry. Just follow the ideas and learn. We'll talk about exceptions in just a moment. Let's finish the last topic for classes and objects. We'll talk about more advanced stuff next week, but for now, this will be the last one, static variables. According to what we said last time, let me just remind you very quickly about what you should know usually when you talk about static versus non-static. Okay, so when we talk about static, first of all, it's a keyword in Java. So if you want to make something static, you have to declare that to be static. So if you say static integer I versus if you just got integer j, the only difference is about the static. Okay, the consequence will be this will be global to all instances of the class you're talking about, right? And this will be local to each instance. That's the fundamental distinction, okay? And we also did the counter test last time. So review that code example I already made available to you, okay? Now, let's see how we can have a useful application for this static versus non-static. Let me propose the problem to you again, and then we'll solve it together to see. Somehow, with a combination of non-static and static, we can do something very useful, okay? Let's see what the problem is, first of all. So this is kind of the class we went over. Oh, I can just switch to iPad. That's fine. I do have that. Okay, so this is about how you can manage account ID. Okay, without the use of static variables, you have to do it manually. What do I mean manually? What I meant was this. If you have the account class, every account should have a local ID. And by the way, this is non-static, right? Just to make a note. This is non-static. You don't see the static keyword. And then every time when you are trying to initialize a new account object, this is one of the inputs. So this tells you anyone wanting to create an instance of account must, sorry, there should be no comma. They must supply an ID themselves. Think how ridiculous this is. If I want to create an account in one of the banks in Toronto, the bank will ask me, can you just tell me what ID you would like? Right? That's like how ridiculous it is. Usually they should choose the ID for you rather than you choose the ID for yourself. Okay? Now, if you look at that, we are trying to create in the tester account 1 and account 2. They should have different unique account ID. And in this case, we simply pass manually 1 and 2. Okay? And then after that, you can simply check to see the IDs are different. Okay? That seems to work. Seems to work. However, imagine a realistic bank where maybe you're trying to add thousands of clients into the bank. And maybe sometimes some clients will actually withdraw from the bank, or sometimes client want to add in to the bank. In that case, ID may have to reassign as well. So that kind of management may not be so nicely done if you do it manually. So this is why we want to see, is it possible to say we want to get rid of this particular input arguments. We just want to keep just one. Whenever you want to create an account, just pass the name of the owner. You don't need to supply the ID. That's the motivation. Okay? Everybody clear about what the problem is? Okay, that's what we want to solve. And the way to solve it is by using static. Okay? Because somehow static can be a shared variable, that's, let's say, integer, that can be shared among all the account instances. Okay? That's basically how things will work. Now, I'll just show you the code directly. Okay? So now, let's see what the change was. The only change we had from this version over here to this version over here, I have highlighted them in yellow. Okay? Those are the changes. Now, change number one, you must declare some static variable that's to be shared by all the account instances. In this case, I just call it global counter. Okay? You can call it GC or counter or whatever, global counter. And then, usually for static, because it belongs to the class, not to the specific instance, I can just initialize that to 1 right away. But initial value can be any value. It can be -1, it can be 2, it can be 10, doesn't matter. Notice that I did not get rid of the non-static ID. It is still there. We still need it. Because each account still should have their ID. It's really about what kind of ID should we assign to them. That's the issue. Okay? So we still have this ID over here that's non-static. And then we have owner, and then, so now notice that for the account constructor, now there's only one single argument, right? Only one single parameter. And notice that no need to supply an ID anymore at this point. That's the change. Now, notice what we are trying to do over here. I'll try to go over the code with you, and then we'll trace it. This constructor over here is going to be called as many times as we wish, depending on how many account objects we would like to create for the bank. And every time we try to create a new account, we'll say, for the local copy of the current account's ID, it's going to be just the same value as whatever the current value is for the global counter. After that, to make sure the next account is going to get a unique ID, we simply increment the counter by 1. Right? Make sense? And then after that, we'll simply set owner to be whoever owner you want to set to be. That's the logic. Logic is simple. Okay? And then when you try to do things like this, let's say I want to create account 1, account 2. You can see I only give the name Jim and Jeremy. And then if I simply try to do the same test to make sure their IDs are different, you'll be okay. You'll simply tell me it's true. That's kind of the code you have to write. Okay? How does it work at a runtime? Let's try to see. Let's say when I try to execute this code, this line at a runtime, first of all, I'm going to call new account for the very first time. That means I'm going to call this constructor over here. And the owner is going to be Jim. Okay? And now that means, oh, before that, remember there's a global counter that has the initial value 1. So that means I should have just set aside, remember this is not an object, just set aside the static variables. So this will be the static variable for account over here. And then I'll just say GC for global counter. Initial value is simply just 1. That's done even before you try to create any account objects. Okay? And then let's go back to here. When you try to create this new account objects here, let's try to see each line. First of all, you're going to create a new account objects over here. And as we know, how many attributes do we have? How many non-static attributes do we have for accounts? Apparently, GC should not be included, right? In each object. Should ID be included? You should. And owner should be included, so we got 2 attributes, okay? So now we have over here ID, and also we have owner. Okay? So now what should ID be in this case? Yeah, that's 1. Depends on what the global counter is currently. It is 1. So that means we're going to set ID to be 1 for this object. And then we're going to increment global counter. Now, am I going to increment number 1 or number 2? Number 2, right? That's a static variable. That's why it's global. That's a critical step. So I'm going to increment this to 2 so that the next account is going to get ID 2, okay? And then after this will be trivial, just set the owner to be Jim, right? And of course, make sure ACC1 is now pointing to this particular object, right? Any questions up to now? That's about the first one. Okay, so far only one object for the accounts in the system. Now let's do the second one. The second one, let me use green. We're going to execute this line here, and then again we're going to call the constructor for the second time. So calling the same block of code over here, and now we're going to create the same object structure for the same class. Account, and we have ID and owner. Now, this.id, this is now referring to this green object over here. And now, what should be the global counter value here? 2, agree? Okay, it's now 2. So now that means we're going to assign 2 into this.id. And notice that 1 is different from 2. That's exactly what we wanted, right? And then after this, we're going to increment the global counter value again so that the third account will get a different value, right? So we're going to increment from 2 to 3. Okay, after that, we're going to set the owner to be, in this case, Jeremy. Okay, and then make sure you let ACC2 also point into here. Okay, that's the 2 lines in the tester. After this, if you try to do this test, ACC1.id is ACC1.id is referring to 1, ACC2.id is referring to 2, so they're different. So now, this mechanism using static variable is completely automated, which means every time you create a new object, it's going to increment the counter itself. You don't have to give a different number each time. That's the advantage. Okay? Any questions until now? So that's quite a nice application for the static variable. And also you want to know the difference between static versus non-static. Okay? Okay, if no question, I assume you're okay. So now let me try to do a little bit more examples for you just to illustrate, to reaffirm the idea. Let's try to consider this. Now, I give you a little bit hints. I call this misuse of static variable, which means there might be something that will go wrong if I code in this way. Okay, let's go over the code together. Let's say we have a client class over here. And then for the clients, we have an array of accounts. So you should be quite familiar with the pattern already, I hope. If you haven't, catch up. Okay? An accounts is simply an array, and also we have the integer counter number of accounts. However, the pattern I showed you before in the class, there was no static for the counter, like NOP or NOA, there was no static. However, now I put a static at the front. That's the only change I made. Okay? Everything else pretty much the same. So now for the add account mutator, I simply say, go to the current value for number of accounts, assign the ACC into it, and then increment the counter. Okay? That's it. The only change was I add static in front of the counter. Okay? Now my question is this going to make any difference at the runtime? Actually, if that wouldn't make a difference, I shouldn't really bother mentioning, right? So that should make a difference, right, if you think that way. However, what kind of difference should it make? I'll give you a little hints over here. Think about if we didn't put static. If we didn't put static, that means the number of accounts counter belongs to every client, right? Every client instance should have this particular integer counter as an attribute. However, by adding static, that means there's only a single copy of number of accounts counter, right? Hopefully that gives you a little bit of hints. Yes?
So like, if we create another instance for the second person,
yeah,
they wouldn't start with 0, they would start with a different number, which would offset everything by that number.
Yeah. Okay, that's very good. That's exactly right. So I'll repeat basically the same. Okay, so basically the problem is, so now the number of accounts which is used as the index into the array is now going to be incremented every time when you try to create a new account or try to add the account into some clients, even though it's not exactly yourself. informally speaking. But let's see exactly how that's going to happen. Let's try to illustrate. Well, I would say expect this kind of question in the written test, because I might just give you something over here and ask you if that's correct or not. Of course, you may choose to type it out in the Eclipse. That will give you some output, to give you some idea. But what I really want is some inside explanation, right? That's really something I expect you to achieve. Okay, but let's try to do it together for this one here. So now this tester over here is going to illustrate exactly how things might go wrong. Let's try. Line number 1, let's see this. We're going to create a new client called Bill. Okay, so we have Bill over here, and then it's simply pointing to some array, let's say only up to 30 accounts, let's say for each client. Let's say that's the case. That's agreeing. And then the second one, we're going to create another instance for a client called Steve. So we have Steve over here, which is pointing to this particular array, also of size 30. Notice that NOA belongs to Bill. A separate NOA belongs to Steve. Is that the correct way to draw it, though? First of all, that might be the mistake you will make. Is that correct? When I say NOA, I simply put it here. Yeah, exactly. So what's wrong here, which I intend to really illustrate over here? If I simply draw NOA like a separate copies over here, that means I treat NOA as non-static. However, it is static, so there should be only a single copy rather than 2 copies. So how should I draw instead? Just a single box, right? Let's do it. Okay? It's really important. So now, let me just erase NOA over here. Just erase NOA over here. Okay? And then what I will do is I'm going to put NOA. Let me say I have the client class. Again, this is not objects. I just say for NOA, there's a global value starting with 0. Okay, that's the correct way to draw it. Okay, be careful. Because if you draw it wrongly, you wouldn't be able to trace the correct behavior. Okay, so that's about these 2 accounts. So now let's try this. This is about these 2 clients. And then the next 2 lines, we're simply creating 2 accounts, right? ACC1 and ACC2. That's easy. You simply ACC1, ACC2. They're pointing to different account object. That one's easy to draw. Okay? So now the critical lines like this. Forget about the comments I'm making there. It's actually for you to study for. Okay, let's just focus on the Java line. Number 1, let's look at what's in pink. Bill dot add account ACC1. Okay? If I try to call this method here with Bill being the context objects, that means I'm calling this block of code over here where I'm talking about Bill, this particular client objects, right? And then I'm going to execute line by line over here. So now what would be number of accounts over here, NOA? 0? 0 over here. So that means Bill dot accounts at position 0 is going to be ACC. In this case, ACC is simply ACC1. It's assigned to ACC1. Right? That's what ended up being executed. So now that means accounts for Bill at position 0 is now going to point to this particular account. Don't you agree? Okay? Guys, I think hopefully it's not too fast, right? Hopefully you can follow. Let's do the next one, which might run into trouble. The next one over there is, let me use red, okay? The next one is Steve now becomes the context object, and we call the same method, okay? Add account and then ACC2. So that means now we are considering ACC2. And now when we execute this same block of code, the context object now is Steve, this object specifically, okay? So now a question for you. Now when we try to execute this line, we are trying to say Steve being the context object dot accounts at position what? That should be the current value for this particular static variable, right? Sorry, I forgot to increments. In the previous stage, in the pink, when I was back in here, I forgot, okay? Back in here, at the end, I should have incremented that already, right? So it should have been incremented to 1 already. I forgot, okay? And now, let's go back to this line here. So now, at this moment, number of accounts is actually 1. Agree? That means we're going to say 1 over here is assigned to, in this case, ACC2. What would that be? That means Steve at dot accounts at position 1 is now going to assign to ACC2 like this. What happened to this slot then? Right? That's the problem. Because we are by following this particular programming pattern, we are supposed to fill in from left to right without any null slots, any null elements. But now we are creating a null elements over here. That's a problem. Okay, let me write it down. Problem: Steve dot accounts at position 1 is never used. Simply just null. 0, thank you. Yes, that's what I meant. Thank you. Okay, that's the problem. Let me just reaffirm if you really understood the issue. Okay, let's say after this, let me just hypothetically introduce 2 more lines for you. Let's say over here, after ACC2, I say account ACC3 is new account, okay? And then after I say Steve.add account, I'm going to add a new line here. I say Bill.add account ACC3. Okay? And by the way, again, I forgot. You can see from the previous line, when I was trying to do Steve.add account, right? At the end, I also have to increment the counter again, right? So that will be from 1 to 2. Okay? That's what I forgot to do. So now, considering these 2 new lines I just added, which array will be changed, first of all? Which array? Would it be the array at the top or the bottom? Up or down? Why would that be the top, first of all? Since the context object we're talking about is Bill, right? So that means Bill at accounts is this particular array. That's what we are changing. Okay, first of all, you should really tell that. And number 2, what will be changed really? I mean, is it okay, apparently we are trying to create, I'll draw it here. Apparently we are trying to create a new ACC3, right? It's going to point to just some new account object over here. But now, are we going to store ACC3 in the next available slot or something else? Should be 2, right? Because that's the counter value, right? That's a problem. So you can see what's going wrong is basically every time you're doing this, you're always opening up some null slots for your array, which is not what you intend to do for this programming pattern. Okay? Questions? Guys, any questions, confusion? It's now time to ask. Right? You first, and then I'll come to you. Yeah. Yes, correct. How do you fix it? Exactly. So somehow, I was just trying to play with the example that we talked about before. Remember, I said you always want to be curious. So you might just ask yourself, since now I learned about how to make a variable from non-static to static, what about just try this integer counter? If I make it from non-static to static, this is what's going to happen, right? So the question was, how do we fix it? To fix it, you just go back to the original pattern we talked about, get rid of static. That'll be fine. However, you are expected to know, if I put static over here, why did it not work? Okay, that's the main reason I'm trying to trace the code with you. Okay, good. Questions? Okay. Guys, any questions? Are we okay? Okay. Good. Okay, and then let's do a final thing about static. That's a final issue. So this is something you might have done wrong, maybe back in 1022. I guess, or maybe when you're trying to complete your own exercises in Java. Okay, let's try to see what's going on over here. Okay, I think I have some slide to go over with you for that particular example. Okay, so that's exactly what we just said. Okay, so now we don't have to worry. Okay. Okay, common error. I want you to look at, first of all, Sorry, that's not the one. That's the one we have already gone through. Okay. Common error number 2. This one here, okay? So now let's consider this particular class. You see, we have a bank class, and then let's say line number 2, we are declaring a non-static attribute called branch name. Maybe it's a CIBC at Mississauga, or CIBC in downtown, something like that. And then line number 3, we are trying to define a static counter, next account number. That's pretty much like a global counter we talk about. And then we also got the another mutated method from line number 4, right? So from line number 4, let's see what we are trying to do over here. I'll switch back to your notes. Now I want you to look at this particular line. System.out.print line. And then I say branch name plus. Basically, intention is whenever you want to actually use some account number, I just want to print something to the console and say, okay, for this particular account, it's actually in this particular branch of the bank. I'm just trying to use this attribute here. Okay? That's basically what I'm trying to do. Okay? And then after that, I'm just going to increment the account number, the global counter, as before. Okay? So now, let me undo everything and make it clean. Question for you. If I try to compile this fragment of code in Java, in Eclipse, would it compile? Okay, good. That's wrong. No. It wouldn't compile. Okay, that's okay. It wouldn't compile. But now, the question is which line and why? Line number, I can tell you that there's no errors like a missing brackets or missing semicolon, nothing like that. Okay, something to do with static. I can tell you something to do with it. Line 5. You said line 5. Okay. If you believe line 5 is going to cause some issue, what would that? Why is that?
You can't access a non-static variable to static context.
That's exactly what you will see in Eclipse. Let me write it out first, and I'll explain. Basically, line number 5 is going to give you a red cross. Eclipse. It's something like this: illegal use of non-static variable in a static context. I'm not sure if any one of you has run into this trouble before. If you haven't, you will, I'm pretty sure. Okay? That's why I'm trying to mention this. First of all, that's what you will see in Eclipse, which may not make much sense. Okay? Let's see why. Think it this way. The justification is very simple. Look at this. If you look at a branch name, is it static or non-static? Non-static, right? Because you can look at that, it's no static in front, okay? So this is non-static. And what is the consequence of accessing, what would be the way to accessing a non-static variable? Create an instance as a context object, exactly? Okay, so that means a context object is needed, which means you have to create a class called bank. You have to create an instance of bank, let's say B1, in order to call this particular branch name. So now, question for you. Over here, line number 4, we have static before the method. I didn't really mention static method, but the idea is very similar. Static method, like a static variable, they simply belong to the class, not to the individual objects, meaning that if I want to call this particular static method, I do not have to create an object of type bank. How can I call this method then? I can simply use bank, right? So now this is static method. And that can be accessed by writing bank dot use account number. Okay? Do you see any contradiction over here? The contradiction goes like this. When I am trying to call this, oh, sorry, I made a highlighter. When I was trying to call this particular method over here, right, I did not have to give any context object. This is not a context object. Okay. However, inside the definition for this particular method over here, it requires something that is non-static, which will require a bank object. But bank is not a bank object. That's a problem. Guys, do you follow? Make sense? Let me say it one more time, just in case you didn't catch me. When I am trying to make this particular method call, I can do this using just a class name, simply because this method here was declared as static, number one. Number two, inside the definition for this particular method here, is using an attribute which cannot be just be accessed using a class name, because it is non-static over here. So you should create a object name for sure in order to get access to it. That's why you will actually see this particular error in Eclipse. Illegal use of non-static variable, in this case, is the branch name. In a static context, in this case, is the use account number method. Okay. It's a tricky one, but you should know. Basically, every time you're trying to declare or define some static method, inside every variable must be static, every one of them, if you're trying to refer to any attributes. Okay, any questions about this? Yes? Okay, good question. What's the solution, right? Very good. What would be the solution for that? Okay, let's talk about it. The solution, there are two possible solutions for you. Two possible solutions. Okay, let's see this. Okay, up to now, I'm just written form of what I just explained. So that one you can just go over the slide, has been covered already. What will be the solution? There are two possible ways to fix it. Okay, two possible ways. Before I go over the solution with you, I will just create a new slide on my iPad so I can go over that together with you. Okay, solution number one. We can remove all the uses of non-static variable. That's one thing we can fix. Okay, if I go back to here, sorry, right here. This is the original code, right? That will give you an error. Solution number one, I use red. You simply, for example, get rid of this. Meaning that if you want to make this particular method as static, you better not use any non-static. Okay, just remove it, then that'll be fine. That's solution number one. Okay. What would be another solution though? You do something that's kind of the opposite way. You make a branch name static. That's what you meant, not bank. You cannot make a class static, right? Good. Okay, that's exactly right. So the second one is actually to make branch name static. Okay, I'm just solution number two. I'm gonna using orange. Solution number two, you keep the branch name over there. Oh, thank you. Sorry about that. Solution number two, keep the branch name. However, I'm going to put static over here. That'll be fine, because now inside that particular static method, I'm using all static variables, right? You gotta be consistent, basically. I have a question for you. It's more philosophical, right? It's more like a design decision. For the orange solution, I'm making branch name static. Do you think that might be a good decision? Thinking about what static really means. I'm pretty sure you got the answer. I want to see if anybody wants to try as well. Okay, yes?
Because static is something that's used by everything. If you change your branch name in one place, it's going to change it everywhere.
That's exactly right. So if you try the orange solution over there, that means the branch name is now universal for all the banks. So that means I have only one single bank called maybe CIBC Mississauga. If you change that to maybe CIBC Downtown, you'll change for every bank object as well. So it might work programmatically, however, that's not a good decision. Yeah, question, yeah.
Just to clarify, so basically, are you trying to say that you should never really mix static and non-static?
That's correct, that's correct. I would say it's specifically, what's the lesson here? Okay, lesson number one, whenever you're trying to declare a static, methods over here, like this one here, static methods, you want to make sure everything you use over here should be non-static. Oh, sorry, the opposite. Everything here should be static only. That's lesson number one. And number two, we go a little bit further about how you can make decision, how to fix it, right? The decision, well, the two possible fixes go with one single goal. You want to make things consistent. Solution number one, we simply simply get rid of the non-static, right? Simply get rid of it. Solution number two, we simply add static to the variable we're using. However, I'm just trying to show you that based on our understanding about static being global, having a global name for every bank object may not be a good idea. Okay? It just doesn't make sense. Yes?
What about making the method non-static?
You may do that as well. So you mean to, oh, I see. What you're basically saying, there's another solution you're suggesting, right? No problem. Let me just post it here. What you're suggesting is, we can also try, let me use red. If you simply get rid of this particular static, that will also work, because now branch name is non-static. We can basically go back to where we were before we talk about static keyword, right? That would be fine too. Yes, absolutely. I should have included in my slides. Yeah. Yes?
But would that mean we wouldn't be able to use, like, that every branch could not be able to use the method use account number?
Yeah, of course, there's a catch. I'm just trying to say syntactically how you can change it so that it will work. Which version you should really go with? Solution 1, 2, or 3? It depends on what you need for your application. Yeah. Good. Are there any questions, please? Okay, so that will actually draw a closure on this particular huge lecture notes about classes and objects. I would say you don't want to wait until Friday. I would say for now, you want to start studying for these classes and objects. It will be covered in both your written test and also in the programming test in some way. Okay? You should really start. I got a question somewhere. Yes?
In the third solutions,
Yeah.
so the next account number will it work? I mean, because it's static.
Ah, that's good. That's very good. In that case, I tell you what, in order for this solution to really work, since you get rid of this, right, you may want to get rid of this as well. Right? So you got all non-static. Again, would that be really something you want, even though it compiles? That's up to you to decide. It may not be what you want, right? I guess.
You want it to be static, but use it function.
Say that again?
If you want to the number, the line 3, let's stay static, but we use it in the method, how can we do it?
No, you cannot do it. So your question was, if we keep this particular version over here, okay, like that. So this actually would not be good because you can see next account number is actually static. You cannot use static inside non-static. Okay? Yeah. Anyway, question?
What about the passive branch name as an argument to the user account number?
User account number, yeah, you may do that. Yeah, I'm just saying for this particular case, I'm just making that an attribute. Yeah, you got maybe choices. Yeah, but yeah, good. Okay, yeah.
So if you have a different branch name, you also just have like make them specify what they call.
Yeah, of course. I'm just trying to put a particular design. It may not be the best design. I just want to illustrate when you try to use non-static inside static, you have issue. That's the main lesson, right? Absolutely, this is not the best design you can have, for your class. Yeah. Good. Okay, so now let's move on to a new topic, right? So we still have to cover today and also next Monday and Wednesday before our review session on Friday. I'll send you maybe I'll do some Moodle poll to see which time I work for you the best, right? Just to find out. Okay, I'll be in touch about that. Okay, let's talk about exceptions. So we may have to go beyond today's lecture a little bit until Monday, but we'll definitely finish that soon, exceptions. But it's quite an important topic, okay? Did you guys do any exceptions in 1022? Did you think that was in-depth, or did you only do throw something, right? Let me just talk to you the whole story, right? I think you deserve to know the story at this level, okay? So we'll go a little bit slowly, that's okay. Yeah. Okay, first of all, I'm going to distinguish this terminology very quickly. That's going to be referred to throughout the course. Caller versus callee. Anybody knows what's the difference between these two terms, caller versus callee? Basically, caller is something that calls somebody else. Callee is someone that's being called by somebody else. That sounds a little bit vague, but let's have a look. Now, let's have a look at caller versus callee. Okay? You can also see the slides. Okay? So now let's see this. What's a caller? Caller is simply trying to use the service provided by another method, basically calls another method. And what about callee? The opposite, if some method is being called by another method, that's a callee. Okay? Providing service to another method so it can be called. Okay, let's have a very simple example to clarify the context. Let's say now we have a class called C1. Okay? Inside class C1, we have a method called M1. Okay, we have a class, we have a method. That's the context we're talking about. Inside the class, inside M1, we declare O to be of type C2. Let's assume C2 is somewhere else. Let's assume. Okay, and then create C2, create O to be of type C2, and then now we call O dot M2. Assuming that M2 a method from C2. Okay? And you do not have to worry about static type for now. You don't have to. Okay? It's actually for future reference. Okay, are we clear about the setup here? Okay, let's now learn about caller and callee. Okay? So now in this case, okay, let me just clear this a little bit. Okay? So now we actually say, in this case, caller. Usually when you say the caller, you want to give both the class name and also the method name to be clear. Caller is under C1, the class. Inside M1, this is the caller. Because inside this context over here, we are trying to make this particular method call. That's the caller. Okay, what about callee? Callee over here that's being called. In that case, we have basically C2 and M2. It is M2 from C2 that's being called, so that's a callee. Okay, caller and callee. Okay. Are we okay with this? Okay, we're gonna see something more complicated for sure, but I want to build the basics first. So now, a very simple question for you. Can a method, for example, M1 or M2, for example, now M1 is actually a caller, M2 is actually a callee. Is it possible for a method to be a caller and a callee at the same time? Is it possible? Okay, seems to be yes, but how can you give me one example? For example, can you give me, let's just do one example. Can you somehow extend the code a little bit so that, okay, I'll keep the caller and callee over here. I want C2 and M2 to be caller and callee at the same time. At the moment, we know C2 is already a callee. We know that, right? At the moment. How can we make C2 a caller as well? How is that possible? What should we change? The class, or specifically, we have to go to this particular method, C2 and M2, and let it call something. Agree? Okay? So what we should do over here, I'll just sketch the idea for you. Basically, we have to go to class C2. Under C2, we know we have the method M2, right? And now, M2 is being called over here. But now let's let it call something. For example, I'm just running out of space. I can say, let's say we have another class called C3. You can say C3, let's say object O2 is assigned to new C3. And then I can say O2 dot maybe M3, assuming that M3 is in C3. Okay, let me write it more clearly. M3 over here. So now in this case, for C2, M2 is also a caller as well, right? Okay, so it's definitely possible. This is why I have to introduce these two terms to you, caller and callee. You will actually need to use this to understand exceptions. Exception itself is actually not too bad. You just got to know the syntax. But I think in order to understand the runtime behavior for exception, you have to know caller and callee very clearly, especially if there are multiple classes involved. Well, that's something we'll go through together. Okay, assuming that you're okay, so get used to caller and callee, right? I'll keep using them. Okay, so now let's talk a little bit about error handling. Okay. Before we know about how you can handle errors using exceptions, we want to know what if you don't have exceptions available to you. What can you do? Print statements, agree? You might just simply print something to the console or print something to your Android tablet screen, right? Either way. Okay? You can just print something to say, oh, something has gone wrong. It might be okay when you have simple applications where you have only one or two classes involved with each other. Actually, even for two classes, you might run into trouble. There's a fundamental limitation for using consoles or screen to report the errors rather than exceptions. We'll see. Okay? I want to illustrate to you. Let's consider a simple class, first of all. Let's say we have a class called circle, which has a radius attributes. And then also we got constructor over there. Let's say just set it to be 0 by default. And we have set radius over here, which will simply take some radius value. Okay, so now we do some very nice error handling. We say if r happens to be negative, we're going to print out the error to say invalid radius. Okay? And then we say otherwise, we're going to set a radius to be r. Okay? Make sense? Okay? And also we have an accessor here which will get an area, right, for the current circle. Very easy class. Okay? Okay, so you can read it through, just to reaffirm your understanding. So basically, if something that goes wrong, for example, if I pass -5 over here, it's going to print something to the console, right? This class by itself might be okay, but the problem is, in reality, you don't really work in one class in isolation. You have to collaborate different classes. Let's see a scenario. Let's say we have another class with a main method. So this can be run as Java application. It's called circle calculator. Okay, so let's say we have circle C, just a new circle. And then we simply say c.setRadius -10. At this point, we know that it's going to print something to the console as an error to the user. And then after this, after we set a radius, we're going to say the area should be c.getArea. Okay, just get an area, assuming that the radius is valid. And then after that, we're going to say print line, area should be whatever area we calculated. Now, can you anticipate, can you imagine that things might go very wrong? Not really wrong, something might go very strange at the runtime. What's going to happen at the runtime? Yeah, exactly. What's going to happen is, if anything goes wrong in line number 4, if I give -10, for example, in that case, what I should have done is to stop the program somehow right away and to handle the error. However, simply do system.out.println the error from line number 4 is not going to break the flow. It's going to let the flow carry on to line number 5. So what do I mean? Let's now do a very quick demo on Eclipse. Okay, you also got a source code already. If you go to the exception circle and bank, you'll simply go under source, go to circles without exceptions. Okay? So now if I go to that particular class, okay? Yeah. You can also read the comments in the code I wrote for you, so you can study that. For example, you will see that over here, enter radius, if I simply say 5, it's going to say that's particular area. That's fine, no problem. However, if I try to say enter radius, I say -5. Now, what I really expect to see at least is that the area should not be calculated, at least. However, if I go further, it's going to say error, invalid radius -5.0. However, the program still go ahead to calculate the area. In this case, just some wrong number, of course. Okay, that's really the big problem for this particular one. Version. Guys, any questions up to now? I just try to illustrate the simplest example to show you that system.out.println some error is not enough. The main problem is over here when you try to do -10, and then when you reach this particular branch, minus 10 is going to make it true, so it's going to give you invalid radius. Okay. However, this is going to print to the console. However, this part over here, this will still be executed. That's not something we want. We want to say ideally, as soon as an error happens over here, we want the program to stop or pause right away to handle the error right away, rather than going further. That's the issue. Okay? But with just console messages, we cannot achieve that. Questions about this? Okay, hopefully that's clear. Okay. So now, let's move on to another slightly more complicated example where I'm going to introduce a new term. Okay, you can read it through. Okay, exactly what I said. Oh, look at here. The solution, which is exception apparently, which we're going to show you eventually. We want a way to force the main method over here, the caller for this particular set radius method. We wanted to actually realize there's something that has gone wrong and stop over here somehow. Or at least we want to force the caller to handle the error right away, rather than going further with your the code. Okay? Okay, let's see another example here. Okay, this one's slightly more complicated, but I do want to explain call stack and also call chain. So these are also important concepts when you talk about exceptions. Okay? Let's say we have one class over here called account. We have an integer ID and also double balance. And then we have the, when you create a new account, you simply pass the ID. Of course, you could have used a static variable to achieve the ID. Let's say we don't do that. Okay? Of course, you should have done that. You should have done that way. And also we got deposit over here. So now, what would be the error condition for deposit, for example? What should be considered as an error? Yeah, exactly. You should not be able to deposit minus a million, right? That would not be too nice. So you would say if the amount I try to deposit is less than 0, again, let's say without the exception, simply print to the console. And then we'll say else balance plus equal A. Okay, that's good. And then we have withdraw as well. Similar. Withdraw, I was just using the logical OR over here. You're going to give invalid withdraw either because you're trying to withdraw minus a million, or when you only got $100, but you're trying to withdraw something that's much bigger. So either way, that will give you an error. So you should make sure you're also comfortable with using the logical operator, right? We already covered also short circuit. That's something you should also make sure you're okay. Okay, so that's about the account class. Okay, that's the first class. Okay, and then everything here you can read. Okay, already mentioned. So now let's go to the second class. I'm going to summarize the three classes in just a moment, but let's go over. After the account class, we have another class called bank. In the bank class, it's more like an account collector. We simply say accounts array accounts and then number of accounts, right? Similar pattern. And then we have so this should be bank, not really account. I'll fix that. Okay? This should be a bank constructor. And then now, every time, if you want to withdraw from the bank, you don't really withdraw from the bank itself. You want to say, given this particular ID of a client, I want to withdraw from that particular client. That's why for the withdraw method here, I have an extra input called ID. Search for that particular ID. If the ID exists, then try to withdraw from that particular client. Okay? And then this amount here. Okay, so what you would do is you're simply going to run a loop starting from 0 until the counter, right? As we said last time, over here you should not really put accounts array.length. That would be incorrect because you know that it's not really every slot has been filled in. There might be some null slots. So you want to say only up to the counter value, right? Because counter value tell you how many accounts are there. And then we say that if accounts, which is the attribute at position I, which is an account, the ID, which will give you the ID, if it's the same as the ID we're looking for, and then we're going to make this particular method call. Accounts at position I is an account. Try to call the withdraw method there with this amount. Okay? Basically, just go one extra level. Basically, over here, we are trying to say, if you want to withdraw at the bank level, you better give it an ID. of some clients we're looking for. Okay? So now, according to what we have in line number 7, okay, look at line number 7. Who is the caller? Caller.
Class bank and method withdraw from.
Good. The caller is class bank and method withdraw from. If you notice, that is green, right? Callee is in red. In this case, we are trying to call the withdraw method in line number 7. And the withdraw method is actually from the account class, as we can see from line number 2, right? Okay, caller and callee. The green is the caller, the red is the callee, okay? Okay, this is the bank class, and that's it, okay? Let's do a final class. So we got 3 classes in total to explain. So now let's say we got bank application and with a main method. And now in the bank application, let's say we have some scanner. Scanner is just a class for you to reading inputs from the keyboard. Okay? The user is simply going to give you, let's see this. First of all, we're trying to create a new bank. Okay, create a new bank objects and trying to create account number 1 with the account ID 23. Okay, that's what we're doing. And then we are trying to add ACC1 into the bank, right? Just calling the normal add account method for the programming pattern. Nothing is wrong so far. And then line number 6, we're basically saying, when you say input the next double, you're saying that I'm trying to read in some new double value from the keyboard. The user might type 23.4 or minus 46.7, something like that. And whatever amount it is, take it from the user, which may be positive or negative. And now finally, in line number 7, okay, we are basically having another caller-callee relations over here, right? So now, caller and callee actually changes again, right? As I can see from the last one, okay? So now in line number 7, caller is, anybody? What's the caller? Yes, the caller is bank application and the main method. Remember the class name and the method. And the callee is the withdraw from line number 7. It is from the class called bank. Okay? So that's a caller callee. So now we got 3 classes so far. Okay? But eventually, when you want to run your Java application, there's only a single class you run. You simply run the class with the main method. You'll say run as Java application, this class. However, think about what's going to happen here. I'll mention it verbally first, and I'll illustrate to you. When I call b.withdraw from 23, the ID, certain amount A, it is actually going to switch the context into the previous class, which is bank, because we're calling this particular withdraw from method. And then the withdraw from method is going to run a loop, and then it's going to call the withdraw method from the account class. In this case, we're going to switch the context to this very first class that we talk about. So there are 3 classes that will be called eventually, even though we only run bank application as Java application. Okay? Let's see exactly what I mean. Let's go to iPad. Okay, let's now see. So these are all the 3 classes, right? I don't need to explain the contents, okay? So now thinking this way. Basically, what's going to happen is we have to run. Okay, so this is going to be run as Java application. This is the class, only this one, okay? So now that means, let me just try to fill out the table and also the call stack, which I am going to explain. Okay, so now, first of all, we're going to have bank application. We'll start with this, okay? We'll start with this class. That's going to be the entry point of execution. And then for that particular class, the caller is going to be, I'll make it complete. It's going to be bank application dot main. Agree? That's a caller. Callee is going to be this particular method, bank and then withdraw from. Agree? Okay, I'm going to use a different color. It's going to be bank dot withdraw from. Okay, that's the first level. So now, as soon as we are trying to make this particular call, we're going to switch the context into bank, right? So now, when we switch the context now is going to be the bank class. And it's this line that we're talking about specifically that will have the caller-callee relation, right? So now, who will be the caller? Bank, right? I'll write it down. It's actually bank dot and withdraw from, right? Withdraw from. Okay, and then the callee is going to be, let's say blue. It's going to be this particular method. And that one comes from, because the account, right? Because we got account array. And this particular index, that should be just single account objects. So now the callee should be the accounts dot withdraw. Okay, so far so good. And as soon as we are trying to make this particular method call, we're going to switch the context to here. Right? We keep switching context basically. Okay? So this is really fundamental idea for you to understand exception first of all, and also later on many other things. So a chain of method call is really common in advanced OOP. Okay, let's finish the table. Once we switch the context to here, so now the context is account. And now the caller should be, so we are basically talking about the withdraw method. Okay, withdraw. So we are basically talking about, now, do we have any caller-callee relation in this case? Are we calling any further methods? No, not applicable. That simply means no further caller-callee. Okay, so now one more thing to show you. The reason that I'm trying to present the method call from bottom to top is as follows. Okay, so there is something called a stack, which we wouldn't really cover in detail in this course. But basically, stack is a very common phenomenon when you talk about runtime execution. Stack, basically, when you go to a buffet restaurant, when you stack up the plates, that's exactly what a stack is, right? So now, I want you to think about the way we try to call the method in the beginning. We simply go bank app dot main. That is the first method we're trying to call. So we put it into the stack, okay? And before we can finish this particular main method, we actually make another call to the withdraw from method from another class, right? So in that case, there'll be a new addition to the stack. So that will simply be bank dot withdraw from. Withdraw from. That's the second one. And now, as soon as we try to call this particular line, we're going to switch the context again and simply go here, right? That means we're calling this particular withdraw. In that case, I'm going to put account dot withdraw. Okay, so now we have a stack. Stack basically is something, there's a property over here that should be easy to visualize. It's called level property, last in, first out. Because bank application was the first class that was being called, so it's put in first. And then we put in bank withdraw from, and then we put in account withdraw. And then later on, when we try to proceed with the execution, this will be the one to continue. And then as soon as this is finished, we're going to remove it from the stack and then go to the next one. Okay? Are you comfortable with this particular table here for the call chain? Okay? That's something you have to keep in mind whenever you're trying to make a method call. Okay? So now, what I'm going to show you is another how to see how we can use exceptions to do error handling. Let's see how much time I have. I got about 20 minutes. Maybe it's time to open up Eclipse and show you how things can be done. Okay? One more thing before I start to use Eclipse. You can see over here, we are still using system.out.println over here. Okay, so this is still errors to the console. Okay, this is not appropriate as we could see from the previous example for the circle. So now the question is, how can we improve it, right? Before we try to improve this bank and also circle, before we do that, we got to introduce you the idea about exception. Okay? To introduce exception, using this first would be a little bit too complicated. I'll use something simple. Okay? let's do something from the Eclipse together, okay? Okay, at least I'll do from my machine, okay? So basically what I will do is I'm going to have a new project over here, okay? I'll just, basically the way I call that, okay, let me see this. Okay, eventually I'm going to type it out. We got class A, we got class B, and we got a tester. We got 3 classes. What we need to see is how exactly we can handle errors using exceptions. Okay, that's what we want to see. Okay, let's see this. First of all, let me go back to Eclipse over here, and I'm just going to create version number 1. Okay, we're going to get 3 versions eventually. So I will have a package here. I will say version 1. Okay, and then I'm going to first of all create a new class called A. We're going to get A, B, and tester eventually. So class called A without a main method, just A. Okay, I will maximize it. So now for A, I will simply get a method here. Let's say void MA, method A. And then it's going to just take a single integer. And then I would say if the integer I'm passing is simply less than 0, then I should give some error, let's say. I'll talk about how you can do error using exception in just a moment. Otherwise, we have to say, simply say no errors, just do nothing. If no error, do nothing. If there's an error, maybe you want to throw some exception or print to the console. But we know that printing to the console is not appropriate. That's not what we're trying to do here. So now, how can we really give an exception at the runtime? You might have seen this syntax before. Let me just write it out. Okay, what you can do is you can say throw. So that's a new keyword you're supposed to learn from now, okay, for exception. Throw simply means give some error. Throw new, and then let me just be precise about what I should type over here. I want to give a new exception that's defined on my own. I would say negative value exception. Okay, first of all, do you remember this particular syntax over here? You can see I'm trying to create a new object over here without giving a name to the objects. That's what we said about in the classes and object lecture. It's called anonymous objects, right? So we're not giving any name. We just throw the object away, okay? And now, since we haven't really created anything like this, so I want to show you Eclipse can actually create a code for you. So now, if you move your mouse over this red underline, it's going to say negative value expression cannot be resolved to be a type, which means it doesn't exist in your projects. One of the options simply is you can create a class called this one. Okay, you can click on that. Okay, and now you already figure out in this particular throw context, it's going to create an exception class for you. So you already got everything here. Especially you will see there's something called superclass. It's something to do with inheritance. We'll talk about it after the reading week. Okay, it simply means a kind of exception you're trying to create. And then just say finish. Okay, as soon as I say that, you can see now we actually got a new class, negative value exception, which extends exception. Okay, that's how you can create a new class, new kind of exception class. Either you simply type it out like this, or you can let it automatically generate to be generated by Eclipse, either way. Okay? So now we have this class for us to use. Okay? If you go back to class A, okay? And one thing I want to show you as well for version 1, so every time you're trying to create a new exception, there's a little bit more to fill in. You want to give an error message over here, right? When you're trying to create a new negative value exception, let's say error, I'll just say error will be okay. Yeah, that means negative error. Okay, and then go back to the exception class. You have to define that particular constructor. Okay, I'll write it out. So you have to say over here, public, the constructor name, the same as the class name, value, exception. And then over here, you just give a string message. And then over here, don't worry about the super just yet. It's also something to do with inheritance. We have to cover a little bit later. Okay. Now let's first of all make sure everything will compile. So may have to, okay. Did I spell it wrong? Negative value exception, okay? Yes. Let's move the mouse over here. I'll read it to you. Line number 7, what we're doing is, rather than printing some error message to the console, now we are trying to throw an exception object at the runtime. However, there is certain thing you have to do in order to handle the exception, right? So now if you simply read the error message, maybe too small, I'll read it to you. It's called unhandle exception type negative value exception, meaning that you're trying to throw this exception here, but you're not really handling it. That's a problem. But how do you handle an exception? There are 2 ways to handle an exception. Okay? Let me show you one of the ways. One way is to say, I don't try to do anything with this particular exception, I just throw it. However, any potential caller of this method should know about this. How do they know about this? So you can see, typically we've just got the return type, the name of the method, and the parameter. Now after this, between the closing parentheses and the opening curly brackets, you got to write something new. Okay? Over here, you have to say, this method potentially throws this particular exception. Just give the name. Okay? That's what you have to write. Throws. Okay? Now everything compile. Let me summarize what I have done. So it really illustrates some basics about exception. What we started with this particular class called A. And then we're trying to define this particular method. And we say that under this particular condition here, we're going to throw some new objects. And the object is of this particular type. However, the type didn't quite exist. But we can just ask Eclipse to generate a class for us, which is an exception. And now, if you look at the exception class over here, okay, you never ever have to memorize this, okay? If I'm gonna ask you this in the lab test, either you can generate using Eclipse, or I will just give it to you. You don't have to worry, but you just have to know how to use it. Okay, you can make a reference to the slides on how to define that. Now, if I go back to this particular class here, for this particular fragment of code, it has the potential to throw an error, to throw this particular exception objects. So now, here is a principle. Okay? I'll write down the principle informally, and then we have to go over that in a little bit later. Okay, let me just have a new page over here. When an exception is thrown, okay, now you have either of the 2 ways to handle an exception. It's so-called a catch was specified principle. Okay, it's called a catch was specified, which means either you try to catch the exception or you try to specify the exception. Okay, you have the specify option, which means include the throws that particular exception as part of the method declaration. That's approach number 1. Okay, let me show you again. If you go back to that particular Eclipse over here, you will see that since we are throwing this particular exception, we should handle that. We are choosing approach number 1. We simply say this method here potentially can throw this exception. That's why it throws. That's approach number 1. Okay, that's specify. You specify as part of the header of the method that it can throw this particular exception. Okay, that's number 1. What about number 2? Number 2 is called catch option. Catch option simply means catch the exception that may be thrown and do something about it. So that's the principle of handling exception. For number one, the keyword you should know is throws. For number two, the keyword you should know is try and catch. Okay, just make a summary first. Okay, you exactly that's what I'm going to do. Okay. Okay, at least we can finish hopefully one or two versions. Okay. Any questions until now? Right? It's just learning the whole process. Okay. So now let's see this. Okay. So now you can see that over here. Let's go back to version 1 here. So now the way I in class A specify the exception. Okay. Let's have one more class. Under version 1, I'm going to create another class called B. Okay, without the main method. So it's a new class. So now let's see this. For class B, I have the following. Very easy setup. For class B, I'm simply going to have MB. Okay, method B. And then it's also going to take an integer value over here. So now in B, I want to call the MA from class A. In order to do that, I need to create objects. Object A is assigned to new A, just default constructor. And then now, if I simply try to say OA dot MA, and then just give some whatever I that's being passed, I just pass it through. Okay. Now, does it compile? It doesn't. Okay. So now the main issue about this is, first of all, let's read the error message. If you move your mouse over, it says that on handle exception type, negative value exception. What's happening is this. When I was trying to call this line number 6, OA.MA, if you go to MA, it throws negative value exception, meaning that when I'm using it, I need to take caution, which means the OA.MA has the potential to throw me back negative value exception. Okay, I'll put it here. MA may throw a negative value exception. That's exactly what we said previously. So now, how do we handle this? How many options do we have, as I said? 2. Either you can say, again, either you can say over here, you can try to specify or you can try to catch. Okay? Let me try to show you the second option. What if I try to catch? What's going to happen? If I simply try to catch it, what I should do is, since this method call is really giving me the caution, right? Giving me the warning. What I should do is I should really enclose it within a try block. Try block means try this particular line of code. Okay? Just give it a try. Okay, I'm going to put this line here. So try. And now, try always go with catch. In general, you may have as many catch blocks as necessary, but for this case, only one block. Okay? I'll say catch. And now, in the catch over here, you want to catch the intended exception that might be thrown, which is negative value exception. So you're going to say negative value exception over here. And then you have to declare that over here. So this part here is more like a declaring a variable. Okay? So now you just say negative value exception. Try and catch. And notice that magically, things just compile right now. I'll make a note. So this line of code may throw a negative value exception. So now we say that we simply handle the exception by catch, sorry. Okay, either specify or catch, like that. And then catch simply means, I'm going to trace the code a little bit more carefully next time, but the catch simply means as soon as if the exception is ever thrown, I'm actually going to give you something like some warning or something. Okay, in this case, I can say system.out.println, for example. Value is negative. And then I'm going to put another line here, system.out.println. And then after this, I'm going to say value passed was okay. Now, I'm going to just mention this quickly, and then I think we're about time. Okay, give me just 1 or 2 more minutes, and then I can finish that next time. Line number 9 and line number 12 are 2 print statements over here. Okay, so now try to imagine this. What's really nice about exception is if error really happens, the flow of your execution is going to be changed in a way that makes sense. Let's say this. Let's say when I call OA.MA, okay, if I call that with a positive value, that's 5. In which case, I wouldn't get exception. And then I'll simply just go to the next line, and then I'm done. On the other hand, if I try to call OA.MA with -2, in this case, as soon as the exception is thrown, I'm actually going to jump from here. Rather than going to the next line, I'm going to jump from here directly to the catch block. So the flow is actually different. Okay? So what you should know for now is, for version number 1, what we just illustrated is, when you actually have some possible exception that's being thrown, you have the catch block. There are 2 kinds of flows you have to worry about. And that's something I'll mention on Monday. Okay? And expect to receive a guidance from me on Friday about a lab test. You want to start preparing early.